During winter, we cover our bodies with hats, gloves, and scarves to keep from the cold. Sometimes the cold wind can breach our clothing through an open zipper on a coat or a badly tied scarf. It's the same idea with heat transfer through the building's walls and roof materials. The air infiltration could be at the window frame or the gap in the doorway. These leaks allow the warm air inside the house to escape to the outside of the house, replaced by the cold air coming in, especially from the windward side. This process of heat transfer is called convection. This is why a house heated by a furnace or by solar radiation can still see the internal temperature drop. Consider a thermos. Warm water inside a thermos loses its temperature after a few hours. This is mainly due to the physical process called heat transfer by conduction. Both the building shell and the thermos are obeying the physical law of heat transfer by conduction. 3 forms of heat transfer exist in our built environment: radiation, convection, and conduction. As we have already learned, the house gains energy through radiation from the sun and loses energy through convection in winter. Conduction is the transfer of heat through a material where there is a difference in temperature. Heat by conduction moves from hot to cold. Our building shell is a kind of thermal media. Heat from indoors is conducted through the shell to the outside in winter. If we look inside the building shell, there is insulation inside the wall, and we have an inert gas inside the double-layer window. The insulation and inert gas can increase the thermal resistance of building materials. The thermal resistance is the resistance of materials to the flow of heat by conduction. By knowing the resistance of a material, we can predict how much heat will flow through it and can compare materials. Materials conduct heat through movement of their molecules. Faster movement means higher temperatures. Slower movement means lower temperatures. If molecules are packed densely, heat transfers faster than if molecules are spaced further apart. Air molecules are spaced far apart, thus heat travels very slowly in air. Thus, materials which contain air pockets are good insulators. The thermal resistance of building materials is largely a function of the number and size of air spaces that they contain. For example, 1 inch of wood has the same thermal resistance as 12 inches of concrete and 1,800 inches of aluminum, mainly because of the air spaces created by the cells in the wood. Usually, the thermal resistance can be expressed in terms of R value or U value. For example, a double-layer glass window's heat resistance could be expressed with this equation of R value, or this equation of U value. R and U value are reciprocal. Higher R value or lower U value means better heat resistance and less energy transfer. Okay, we understand why we lose a lot of energy in winter, because we have low R value walls. We also lose heat by air infiltration, which is a process of convection. Warm air is replaced by colder incoming air that needs extra heating. Sealing the building shell tightly and making good insulation with high R value materials helps to save lots of energy for heating. In the next chapter, we're going to look into removing the unwanted heat from a house in the summer.